Hello, welcome. This is the puzzle game. It's a web app made by Jacob, Claudio, and David. The problem that this was solving is it was a web application for completing a puzzle by moving around pieces and getting a clear visual, putting the picture together from a 4x4, 8x8, 10x10, or 12x12 with different images. The design, the approach was basically 15 puzzle users will enter a landing page and select a puzzle size they intend on completing. From there, they'll be given an option to select a background image and shuffle the current state of the puzzle. So, and upon starting, the users will have infinite moves or tries to complete the puzzle, but there'll be a time limit. And when you get it all correct, it'll get you win, and you can select another puzzle after that, or reshuffle the puzzle to try again after that. And the general interface was HTML, CSS, and JavaScript to create various div blocks to enable various function calls representing the puzzle. Prior to the actual website, images were pulled using JavaScript and would move and shift depending on the position in which they're set. Continuous function for correct would be ran to examine whether the current state of the puzzle was properly organized to make the picture. This is the graph of how the website flow is, where the user will enter the landing page and it'll display the index. And from there, you choose from a drop down panel which puzzle dimension you want from 4x4 to 12x12. And when you select your desired dimension, you can add a background image, which can be an apple, an elephant, or Mario. And you can continue, or you can continue with like a standard format. And you start the puzzle, and you can shuffle it, and you would move around with various moves to complete the puzzle, while the website is checking the current state of the puzzle for completeness. And also, you can move the box to like adjacent empty space. Once the puzzle is correctly organized, the puzzle will end, and you're alerted that you win, and a dimension panel will drop down, and you can reselect dimension of the puzzle and repeat the diagram to the top and restart the puzzle all over again. The testing, it was tested by inserting new HTML and styling and verifying correctness. Additionally, we sat through and discussed various ways to style our page, make it look neat, and ensure that the logic in all aspects of the web app made sense, and tried it on our own to solve it and see if it all worked out, and you can win. The input, it will vary from selecting the dimension of the puzzle a user seeks to complete, as well as a start button to indicate a puzzle start, and shuffle to indicate randomly ordering a puzzle. Main data is stored in the current state of the puzzle through the entire session, as well as background images in our source.
Just a brief overview of the website. Upon landing on the main page, we have our puzzle game, and where we're shown a selection to choose a size that'll drop down a menu, and we can choose from 4x4, 8x8, 10x10, and 12x12. Upon clicking one, we'll be alerted that we can also select either 1 for Apple, 2 for Elephant, 3 for Mario, and 4 for React, and it'll display a background image corresponding with the actual puzzle. An example of this would be here. We can either select, in this case, we've selected 3 for Mario and a 4x4. And so on the right side, we have Mario and a 4x4 puzzle. But in the case that we don't select a background image, we would just be displayed a standard format puzzle. And upon clicking shuffle, all the numbers and variation of the puzzle will be reorganized. You can see both for both examples of a background image and a non-background image. And our puzzle grows. It can, as I mentioned, it can be 8x8, 10x10, or 12x12. And these are just all the different variations of the puzzle increasing size. And upon successfully completing a puzzle, the user will be alerted with the U1, and from there they can select and re-choose and restart the puzzle.
All right, I'm gonna talk about the code. in the website. So right here we can see some HTML with some classes that contain animations. So when the user enters the page, the animation gets triggered. And also as we see, we have some values on some of the objects on the select dropdown. So we can pick that up so use it in the JavaScript functions later. Here is one of the first functions we have in the code. So the element swapper basically swaps two HTML elements with each other. So we used some JavaScript in order to do that. And we also have winCheck, which is gonna how the game works is that we have an array, so we can keep track of all the elements in the HTML. So from there we can create a string before we shuffle, which is gonna be how it's gonna look like after when you win, and we can compare that string later with the moves that the user do. So this is what comes before we swap the elements. We get the two elements we wanna swap, get the attributes. We first swap the attributes, swap them in the array, and after that we call the function I just talked about right here, element swapper. And then we add some animation for the in order for the swap be animated, and then take it off so we don't have errors. Right here, we're removing after zero point 0.7 seconds. This is what shuffles the table. So we first get the space, all the neighbors from the space element, and then from there we pick a random neighbor and swap them. It's in our swap neighbor function. So this is what changed the images for the 4x4 games. So I pulled this from the documentation the professor provided, and the function just takes the image location and formats it and take the position for each cube and put in the CSS. This is the table creator, which is gonna take a row integer and a column integer, and it's gonna create the row and table data for the table, and it's gonna include all the attributes like row and column, so we can keep track. So we can pull them off from the element and keep track on it on the array. So space neighbors, it's a function that basically returns all the neighbors that the space currently has, and it uses another function called check indices, which it just checks if the indices exist in the array. For example, if the space is in the corner bottom right, it just has an element up and it just has an element on the left. So this basically just checks and returns all the neighbors. This is the check index function. So it basically checks if the index exists, and it returns true and returns false if the index doesn't exist. So this happens when we click any cube that the puzzle has. It's gonna check first if it's clickable, so all the elements are table data, and if it's clickable, it's gonna pull the value of it, and it's gonna check with the space element if they're neighbors. If they're neighbors, they're gonna swap each other, and it's also gonna check if you won. If you won, it's gonna alert you won. If not, it's gonna give an animation to a table because you didn't click a neighbor, and it's gonna take out that animation. Alright, this is what happened when we click the start button. We pull up the row and column from the drop down select, and based on that we have some error checking just in case. And if everything looks good, we're gonna check if it's 4 by 4. If it's 4 by 4, we're gonna ask for the user to insert a number for a background. We're gonna pull it from here from this object, and we're gonna generate the table with the background. If not, it's gonna be 8 by 8, 10 by 10, and 12 by 12, and we're gonna generate the table with those numbers, and also show the shuffle button. So this is the end. This is gonna be our YouTube video. This is the GitHub repo, and this is the website link. We're gonna let's pull it up. All right. So this is how the website looks. This is 8 by 8. The timer starts right after we click start. We can move the squares around. If we choose 4 by 4, it's gonna ask for a background, and we can just do it again. Different backgrounds. The timer restarts again, and yeah, that's how it works. So if we complete it like this, we're gonna have a message that we just completed. You want. So yeah, these are. Thank you for listening.